This is example of a testing of a random number frequency. The first one, second, this is second method of a testing of random number frequency, and the first method is a Kolmogorov-Smirnov test. And we taking the example of the KS test in the previous video. In this video, we cover the topic of a chi-square test. And the chi-square test is a second method, and it is defined as a test that measures how expectations compare to actual observed data or a model result. The data used in calculating a chi-square statistic must be random, raw, mutually exclusive, drawn from the independent variable, and drawn from a large enough sample. The chi-square test is also called the goodness of a fit test, because it is intended to test how likely it is to be observed distribution is due to the chance, and because it measures how well the observed data of a data fit with the distribution that is expected if the variable are independent. The second step of the random number testing is a chi-square test, and the first one is a Kolmogorov-Markov test. The second is a chi-square test, in which we have a formula that is a chi-square, that is x square is equal to OI minus EI by EI, where E is expected value and OI is observed number in the ith class, and OI is the observed number in the class, and EI is expected value in the ith class. From the uniform distribution, expected number in each class is equal to n by small n minus EI. For equally spaced classes, n is a total number of observation, and the sampling distribution of the x square is approximate the chi-square distribution with n minus 1 degree of freedom, and where the chi-square method is used when we have a large number of random variables testing. Now we're solving the problem of a chi-square test. This is example of a chi-square test, and it is used for testing the large number of values. For example, when we have a large number value for up to 50 or more than 50 values, then the chi-square test is used. In this problem, we have alpha value 0.05 and check for the uniformity of the given random numbers, and these are random number which approximately 30 random number are here. So first of all, we have to create the table, and in the table the first pass is a class, and then we define n value, n small n, OI, EI, OI minus EI whole square, and OI minus EI whole square by EI. So what is a class? We have divided this number into a total 10 classes we define here, and n is what is a n? N is a number of a random number which we for example, there are 30 random numbers, so capital N is equal to 30, and where n is equal to 10, where we small n denoted by 10, where class is 10. So these are total 10 divided into 10 classes. So we take 30, and small n is equal to 10. OI is an observed number, where EI is an expected number, and EI formula is a capital N by small n is equal to 30 by 10, so EI is equal to 3. OI minus EI, then OI minus EI ka whole square, and then O minus whole square ka divided by EI. So what we calculate in this part, we divided the number of random numbers in according to the these 10 classes. Now dividing the different range, we have to count the random number, so which falling under the dividing the number of range. So the range is divided accordingly, 0.01 up to 0.1, and second range is 0.11 minus 0.20. Next range is a 0.21 to 0.30. Next is 0.31 to 0.40. 0.41 to 0.50, and 0.51 to 0.60, 0.61 to 0.70, 0.71 to 0.80, and next 90, and 0.91 to 1.0. This is a specific range which we define here. Now how we calculate the OI? OI is, that is observed number, and observed number is calculated to count the random number which fall under the particular range. For example, in OI we have to define the range in what number which are lies under the 0.01 to 0.1. So first of all this number, and the second one is this number. So the two number are specified under the range of 0.01 to 0.1. So here 2, next 0.11 to 0.22. So we find out those random number which are lies in between the 0.11 to 0.20. So the number is first 0.12, and after that 0.15, and 0.15 and 0.19 here. So there are total 3 random number which are specified under the range of 0.11 to 0.20, and further we calculate these numbers are accordingly 2, 3, 1, and 4, and AB4. And next one is all the in this by identifying the range of the random number, we get the number 3, and which remains same in the whole column. This 3 remains the same in the whole column. Now we calculate OI minus EI. That means OI minus EI, minus 2 minus 3, that is minus 1, 3 minus 3, 0, 4 minus 3, 1, next one 0, minus 1, 0, 2, 1, and 1. And next one is O minus EI ka whole square. So this whole square is minus 1 whole square 1, next 0, 1, 1, 0, 1, 0, 4, 1, 1. Now OI minus EI whole square by EI means 1 by 3. Next 0 by 3. Next one is 1 by 3, 1 by 3, 0, 1 by 3, 0, 4 by 3, 1 by 3, and 1 by 3. Now we calculate we calculate this number, and we get the result of D, which is 3.33. So the sum of these variables are also 30, because we have taken the random number from this given statement. And now the random number we get D is equal to 3.33 from the table. We could find D naught is equal to D naught, that is 0.5 is equal to 16.9. 16.9 is a table value which we are given in the statement when we have a 0.5 value. This is a table value which we definitely get in the examination if the question will come. And this 16.9 much greater than the value of D. And what is the value of D? D value is 3.33. So D is less than D alpha. So the condition is true, and H0 is accepted, that is a null hypothesis. So this is example of a chi-square test, and it is used for when we have a more than 50, 60, or up to above 100 ranges of given numbers. So thank you.